Hello everyone, I'm really glad to be here, so thanks to the organizing team, it's really cool conference. I'm going to talk to you about algebraic data types, or ADTs for short. It sounds complicated, but it's actually not, it just means you add and you multiply things together. So it should be all right. And what we are going to see is what they are, but through examples, through practical examples, and how they can actually help us make our apps more consistent, just given the way we choose to structure data. So for a quick introduction, I'm Matthias. I live in France, in Paris. You can find me on the internet under the nickname Bloodyall, and I work in a company called Swan, where we provide like banking APIs as a service in Europe, so creating accounts, cards, and payments. And we are hiring, so check it out if you're interested. I'm really sorry about that, but first I'm going to talk about quantum mechanics. And what is it? It's just weird. It's weird things about physics that people don't understand, even physicists. And just, this is a good meme, I really like this, and it actually represents what happens when you look and you don't look at some weird experiment where you like throw an electron on a wall, and I mean, it's weird. And so when people started to like work on the topic, they made like some kind of meetup in Copenhagen with physicists, and they came up with like a weird explanation is that particles, they do their own things when we are not looking at them, which it sounds basically like a scam, but that's what they came up with. And there was this guy, Erwin Schrödinger. He's another physicist, but he didn't like the interpretation because of like reasons. And then to make a point, he created the famous Schrödinger cat experiment, which is basically you have a box, you put some device that reacts to some quantum stuff, and then the device releases poison if the thing happens. And then you put a cat inside the box, because why not, and you close the box. And he says that if the Copenhagen folks are right, it means that while we don't open the box, the cat is both alive and dead, which doesn't make sense, and so that's his point. And so what does it have to do with UI development? It's a bit of a stretch, but I like using the box as a metaphor for what is coming. And second, like the particles or the cat, we actually deal with possible states in our apps. And it can be states that come from user input, from the server. And we usually describe our apps given what the state looks like, how it is structured. And this is where some things can go wrong. For instance, this is a screenshot from Windows XP, where I call that the successful error. And I mean, this is something that we don't want in our apps because, well, it doesn't look good. And, sorry, we invest a lot of money to avoid having this kind of things in what we build. We have linting, we have static analysis, testing, typing, QA, monitoring, all of that. So that's a lot of money that goes into avoiding this. A more subtle thing that's really into a lot of application is inconsistent loading states. For instance, here I have a spinner that indicates that the data isn't there yet. Still, at the top, it shows like I have 0 jobs in my pipeline, but the application has no way of saying there is 0 jobs because it doesn't know, it doesn't have the data. So while loading, it shows me incorrect data on screen. And we can also have unhandled errors that make the application crash completely or like go to a blank page on the web. And actually, we can avoid these kinds of bugs by managing 3 kinds of states differently. And almost virtually every application has to deal with these. So presence, success, and completion. So presence is I have a value that might be there or might not be. Success is I have an operation that can succeed or fail. And completion is like I have a value, but it's going to get there at some point, but I don't know when. So we are going to start by seeing how we can manage presence. You can imagine that this is a stupid example, but bear with me. You work on a smartwatch company. And the product team comes in and asks you to put a snarky banner if the user didn't wear their watch or didn't do their workout on the previous week. And luckily, you have already an array of data. So you have an object of type day if you have tracked data, or you have undefined if the watch stayed on the charger for the day and the object wasn't initialized. And given the case we're in, given we have a day or not, we need to display a nice message to the user. And so if we take the simplest approach, we use array.find. We are trying to find something in the array. So we check if we have a day that hasn't been initialized or a day that's been tracked but that matched the predicate that the product team gave us. And we might have an issue with that, because if we have a look at the type signature of the function, so this is from the TypeScript definitions, and we can see that the T at the top is the value type of what we have in our array. This is called a generic. And so the find function, it takes a callback, it's a predicate, it takes a value of type T, and given if you return true or false, it will match or not match. And given this is a placeholder, we can replace it by what we have in our array. And we have a bit of a situation there, because we have two situations where the function returns undefined. And that's because null and undefined, they both work in the same way. They take the place of the value that's not there. And so you can't have a representation of nested optionality using these types. Everything is flattened by default. And if you want to implement the thing the right way, the correct way, most of this code is mostly noise. It's just there to satisfy the fact that null and undefined are broken. And this is code that has nothing to do with what we actually want. It has nothing to do with the domain. So our issue is that undefined works a certain way, and we can try to model optionality in another way. So we can take back the concept of the sealed box and have that represent our value. And the sealed box, it can contain a value or no value, but we only know when we open it. And that comes from functional languages that have no concept of null or undefined. They just have another way of dealing with optionality, and it's through what they call the type option, or maybe type in some languages. And it's what we call a union type, and it's either some value or none. And if we go back to our example and we start modeling using the option type, we have the array with optional days. And if we have a little find function that returns an option instead of a nullable value, an undefined value, we can do again the thing where we replace the placeholder. And then we can notice that something is a little bit different in the return value, is that we can nest options because you can put a box in another box. And I mean, it's like an intermediate step that enables you to represent at which level the nullable value is. And so from the value itself, the value that's returned, we can completely infer in which case we're in. If we have an empty box, we found nothing. If we have a box containing an empty box, we found some date that hasn't been tracked. And if we have a box containing a filled box, we've found a day. And now, using this type, our code, it actually represents the domain, and not in any way the implementation details. We write code that really just does what we want it to without having it to please the language, because the language is broken. Now we are going to talk about managing success. So in most programming languages nowadays, the default way to handle errors, it's exceptions, and the way they work it's fairly weird when you think about it, because you have a function that can fail, and the function in its type signature returns like the value if everything goes right, and it throws an exception if something goes wrong, meaning that all the lines below aren't executed, and it bypasses the whole execution flow in the call stack until it finds a try-catch block. And in TypeScript especially, these errors, they don't go into the type system because it's really hard to track in JavaScript, and like some languages have that, but I don't think it's going to happen anytime soon in TypeScript. Small warning, I'm going to have a hot take right now. Exceptions are the worst way of dealing with errors, because most of the time, the thing is, errors, they are part of the domain. If you expose an API, you expect input that can be invalid. And so not having it in your type system is just wrong because, well, it's not in your type system, so it doesn't exist, right? And on top of that, the idea that it bypasses the system and that you have to manage this try-catch block, it means that you don't know if you are handling something that doesn't need to, or if you are missing a case, because you can't control the whole call stack and you can't remember that. And if you work as a team, it's even worse. You can't know at which point it's done. And I firmly believe that when you import a function, its type signature should give you a contract strong enough that you know what's happening. And this is not the case with exceptions. They break the contract. And we can, as we saw in the earlier talk, we have the same problem with promises. Because promises, if you throw an error in then callback, it becomes like the rejected value of the promise. So it means you can't type it at all. And luckily, there is another type of box that can manage that. It's called the result type. It's also sometimes called the either type. And it's the same concept. It's a box. It either contains the value when everything goes right, or the error. And what it means is that your type system now has the full knowledge of everything that can happen within this function. And if we take an example here, we have a parseInt function that takes a string, and we can have, right from the signature, all the possible errors that can happen. And as it's just a value, you can carry it around, you can pass it to function, you can store it the way you want. And here, this is using TS pattern, which is a great library to have pattern matching until the TC39 finalizes it. And you can extract the value from it, and you can have this nice flattened view of everything that's going on, and you can have exhaustiveness checks, so you are sure that you handle all the cases. It also makes the error handling explicit, because it's really like a side effect, but if you have a value of type result, it means that you have to manage the extraction yourself, and if it's not, it's already been taken care of. So by default, you don't have the question of, has this been managed or not? And I mean, it's easier. Last but not least, we are going to talk about completion. And we can take this screen again. So if we look at it, what's wrong in it? And we can wonder, to get in this state, how was it structured? And it's most likely something like this. I'm sure that you've seen something looking like this in a lot of React apps. And there is a lot of problems with the structuring your state like this for data that can arrive in the future. First, this is a structure that doesn't help you manage all the possible states, because the things, they are tied together. Sorry, the things that I'm going to, yeah, the loading state is separate from the the data. So you don't need to check that the loading state is ready before you can access the data. It doesn't encourage you to fix that. Because there, I can make a wrong assumption telling myself like, okay, I can access the data with the optional operator, so must be all right. And it's not. And on top of that, if we create a little spreadsheet of the possible combinations that the structure allows, we can be a bit surprised. Because while we have 4 perfectly legitimate cases, like I haven't started the request, I'm loading, I got a successful response, and I got an error response, we have twice as many cases as we want, because the 4 on the bottom, they don't make sense at all, because you can't have something that's loading and done and in error at the same time. So that's legit, and we don't want that. And the reason for that, and that's the algebraic part, and it's really simple, is just that in this kind of structure, the number of possible state counts, it's all the state count for each field times the other. Meaning that if you have 3 properties that can have 2 types of value, then you get 8 possible states. And we can probably fix that with another box. And this is called async data. I mean, it can have many names, but the idea is you have the same way of structuring it, and you have only 3 cases. The way you use it is pretty simple. You don't have to manage the state yourself like you do in like the objects that we saw, because you just pass the value saying it's loading, and then you pass the value saying it's done. And we don't have the problem of generating the wrong states here, because it's just 3 possible states. So congratulations to you. You all know algebraic data types now. It's just sums and product types. That's what they are called. So a sum type, it's a union type. So something or something or something. And a product type is something times something times something. And that's it. That's all there is to know about that. And so the product type, it's like tuples and objects. And if you want to have like a good rule of thumb in TypeScript for that, when you have a pipe in a type definition, it's a sum type, and if you have like a comma or a semicolon, it's a product type, and that's it. Sum types are really great, especially when you compose them, because like they are sums. And if you put a result type to handle like the possible success or failure of a value within an async data type, you only have the 4 possible states that you want. I've created a little demo. I'm going to share the link on GitHub later. It's a small application that loads a random person from an API, and we should have 4 possible states. So the initial state on the top left, it's like the initial screen when you didn't perform the request yet. You can try to load the user, and sometimes it will give you a user, sometimes it will not give you a user, and it can fail. So we have 4 possible states. And if we compare these 2 ways of structuring the data, well, we can see that the first one can actually not represent what we want without extra code. Because we realize that writing code to manage all these states when you have an object type to represent that, it's really hard to read, because you get all these ternaries when you are trying to like use expressions in like JSX or something like this. And there is another thing, it's that this bit is never hit, because given the API can return us no user, it has like structurally no difference with the initial state, meaning we cannot represent the first one, the case where we return no user. In comparison, if we use algebraic data types, again with TS patterns to get the nice pattern matching, we can see that it reads pretty well, I think way better than the nested ternary. And we hit all the cases we want because each type actually represents a single thing and a single possible state. And so it makes our application like nicer and more consistent. So if you want to play with it, it's on GitHub. You can set up the repo and you can run it and try it. I didn't like do the live demo because it's not very visual, because it's just a random API and like I can hit the thing 10 times before I get the case I want. But you can try it. And if you want to use these nice types, we've open sourced a library that does exactly that, luckily. It's like heavily inspired by Rescript. I don't know if you've heard about it. It was called ReasonML before. It's basically OCaml with a JavaScript syntax. And I changed companies a few months ago, and so I had to work with TypeScript, which I'm not going to comment. And and so I missed this a lot because it like makes you way more productive when you have all these types to manage complex states. It gives you a simple way of thinking about them. And so what we did is like we just created the simple building blocks that you mostly, like in most cases you need, like the 3 that we saw plus some of the nice things. But what we focused on is like provide a good DX, and it's really hard in TypeScript to provide a good DX when you want to deal with algebraic data types. We wanted to make the API really small. You don't have to learn a lot of concepts. And we also worked a lot on making the autocomplete work good, which is a pain. It's like a good fit for React because all the data structures, they are immutable, meaning you can like pass them as props, store them in state, and it will work nicely by default. We also try to make an effort on the documentation so that you don't need a computer science degree to read the docs. And like, we don't explain monads in it, even if it's monads, but we really try to give you cheat sheets and like schemas and stuff like this just to explain the concepts. And we also have like some other niceties like cancelable promises, which I think is pretty useful when you deal with React applications. So if you want to try it, you can like check the doc, check the GitHub, and install it. And I mean, it's easy to integrate in an existing code base because it's just a library with values, and you can like take it and drop it as you wish. It's not something that you have a strong commitment to give. Now, to conclude, we deal with a lot of complexities in our apps, and we like put a lot of mental energy into managing accidental complexity. And that's because we don't delegate as much as we can to types, because types, they are a simple tool. It's simpler than a linter, it's simpler than a lot of things, and it makes your app really easy to reason about. Because when you model states, you just have to wonder how many states can this value be in. And does my structure allow all the cases I want? Does it allow some that I don't want? And then working on this, you will develop a certain intuition really quickly and make your code really clearer and easier to maintain and less error prone. It lets you focus on what really matters, so giving good UX, good accessibility, and not like shooting yourself in the foot and hating yourself for the code you wrote 6 months ago. And it lets you like make your product great. And that's it.